Hi, in a previous video entitled Compressor Receiver Assembly Overview, Andy Smith discussed how all pressure vessels need to have a nameplate attached to the air receiver under the Pressure Systems and Transportable Gas Container Regs of 1989. Today we're going to look at how some of that information will be used. The nameplate for the air receiver is shown. The main information we're going to look at today is the hydraulic test pressure and the designed pressure. Both of these are given in PSI. We're going to test that the air receiver is suitable for holding that air pressure of 250 PSI, and we're going to use a hydraulic hand pump to do this. The gauge on our hand pump is calibrated in bar, so we need to convert 250 PSI into bar. 1 bar is roughly equivalent to 14.5 PSI. So the test pressure we'll be looking for is around about 17.2 bar. We have prepared the air receiver by disconnecting it from the compressor and the pressure valves and blanking off all the ports to the air receiver. We've attached a hydraulic hand pump through the main port at the front and filled it with water. Now we'll begin to pressurise it up to the 17.2 bar, which is the hydraulic test pressure. The current shot shows the pressure in bar that the air receiver is under. We'll leave this for a minute or two just to prove that the welds and everything are still intact and the receiver is capable of storing the pressure it was originally designed to do. The air receiver has been left for 2 minutes and has held the pressure at 17.2 bar. This proves that it is still intact, still capable of holding the pressure it was designed to do. Now we'll relieve the pressure in the receiver by opening up the valve on the hand pump and draining the liquid back into the receiver within the hand pump. We've now moved to the hydraulics workshop. The purpose of using the hydraulic working pressure or design pressure to set up the pressure relief valve. The valve is made up of a number of components. Firstly, we have a reducer which just enables the pressure relief valve to be connected to the pressure. The reducer has a hole through the centre of it. This would allow any air pressure within the receiver to escape. To prevent this happening, we attach a valve seat to cover up the hole in the reducer. So the valve seat sits on top of the reducer. This is held in place by the valve stem, the spring, and the guide bush helps keep the spring in place. That would sit directly on top of the valve seat and hold it in place. How we're going to use the working pressure or design pressure is to set up this spring pressure so it is equal to the design pressure. What would happen then is if the air pressure gets higher than the design pressure, the pressure in the vessel would be able to compress the spring, create a gap, and the air would escape through the slots which are cut in the valve body. We now have the pressure relief valve linked up to the hydraulic pump. We're going to begin to pressurise it and see on the gauge what pressure the valve seat lifts at. As you can see, there's water leaking through the pressure relief valve at around about 2 bar. To alter this, we're going to alter the pressure on the spring by taking it in 2 full turns. And again, we'll try and pressurise and see what pressure the relief valve holds now. After taking it in 2 full turns, the pressure begins to release at around about 8.2 bars. This is close to the working pressure. What we'll do now is adjust this locking nut so that the spring pressure will remain constant, so the nut doesn't vibrate loose when the compressor is working. We'll check that again now, so pressurise it again, and again begins to release at just over 8 bar. So we're quite happy that the relief valve is set up as per the design pressure or working pressure.